Hi all, welcome to this demo on simplifying data lake access control using trusted identity propagation feature of AWS IAM Identity Center with AWS Lake Formation and Amazon S3 Access Grants. My name is Shaukat Ghosh and I am a specialist big data solutions architect with AWS. Let's try and understand what is trusted identity propagation in AWS IAM Identity Center. We will refer to AWS IAM Identity Center as IDC henceforth in this video. AWS IDC simplifies data access management for users and improves the sign-in experience across multiple AWS services. Many of our customers use a number of AWS analytics services. Also, many customers use external identity providers such as Okta or Azure Active Directory to manage their enterprise user identities. These users use various AWS analytics services to interact and execute their analytical queries. Without trusted identity propagation, the user identities from the external identity providers assume IAM roles in AWS, and the data administrators apply access policies on these AWS IAM roles or users. Also, the different services can use different IAM roles to access the data, and hence, as an administrator, customers have to apply the permissions on each role. This can get cumbersome at scale in certain use cases. So customers need a unified mechanism to simplify the data access management using corporate user identities instead of IAM users or roles. AWS Identity Center's trusted identity propagation, which is based on OAuth 2 authorization framework, solves this challenge. With trusted identity propagation, data access management is based on a user's identity, which could be synced to AWS IDC from external identity providers using SCIM protocol. Integrated applications exchange the OAuth tokens, and the token is propagated across services. This enables administrators to grant access directly on existing user and group memberships federated from external IDPs instead of AWS IAM users or roles. User access to AWS services and other events is recorded in service-specific logs and also in CloudTrail events. So the auditors know what actions the users took and which resources the users accessed. Let's see how the trusted identity propagation permits your workforce identities to be used across AWS Analytics services. To better understand, let's look into this architecture diagram, which we will also see in action during the demo. In this demo, we use Okta as the external identity provider, but you can also use other identity providers like Azure Active Directory. Users and groups from Okta are synced to AWS IDC. In this case, we have three groups: Group 1, Group 2, and Group 3. And user 1 belongs to Group 1, user 2 belongs to Group 2, and user 3 belongs to all of the groups. We will use AWS Lake Formation to centrally manage the permissions to the Glue catalog tables. AWS Lake Formation provides a RDBMS style permissioning model to grant or revoke access to data catalog resources such as databases and tables. The underlying data is stored in Amazon S3. The other mechanism we will see is using Amazon S3 access grants. Amazon S3 access grant help you manage data permissions at scale by granting S3 access to end users based on their corporate identities. Let's look into the flow now. In step 1, user identities are synced to AWS IDC from Okta. A Redshift administrator creates a Redshift data share for a Redshift internal table, seen as step 2 here. Now this Redshift table is accessed by a user, for example, a data engineer using Redshift Query Editor v2, and could also be accessed by a business analyst to build dashboards via QuickSight. In this demo, we will use the same user to access both Redshift Query Editor v2 and QuickSight, but in practice, this can be completely different user personas. Further, we will use IDC enabled AENA workgroup, and that needs S3 access grant permissions for AENA query results S3 location. So in step 3, we will create S3 access grants for Amazon AENA result S3 location and grant permissions to the specific user or group.
With this feature, you can also enable the creation of identity-based query result locations that are governed by S3 access grant. These user identity-based Amazon S3 prefixes let users in an AENA workgroup keep their query results isolated from other users in the same workgroup. Note that here we grant permission to only the S3 result location and not to the actual glue data catalog table. In step 4, we create an S3 access grants to a different S3 bucket which is not managed by lake formation.
In step 5, AWS Lake Formation Administrator grants access to the glue catalog database and table to user 1 and user 2. The Lake Formation admin also grants access to the Redshift data share to user 3. Next, the users connect through the various interfaces, and we will see in the demo how the permissions are enforced. User 1 connects to AENA Query Editor via EMR Studio and accesses the table governed by AWS Lake Formation. User 2 connects and accesses the same table using an EMR Studio notebook to execute Spark queries on an EMR cluster. The EMR cluster uses a security configuration which integrates with AWS IDC for authentication and uses AWS Lake Formation for authorization. User 2 also accesses the S3 data location, which is controlled using S3 access grant from the same notebook. With this kind of hybrid access management, you can use Lake Formation to centrally manage permissions for all your datasets catalog to glue data catalog, and you can use S3 access grant to centrally manage access to your raw data, which is not yet cataloged to AWS glue data catalog. This gives you flexibility to access data managed by any of the access control mechanisms from the same notebook. And all the data access requests by the specific users are logged to AWS CloudTrail, and we will see some of the CloudTrail log events in the demo to verify the same. Let's look into the demo now. For the demo, we will take specific users in this diagram and enable access to the users one at a time. Let's start with user 2. So we will set up EMR Studio and EMR cluster with IDC integration, and the user will access the glue data catalog table and the S3 access grant control bucket using Spark queries from EMR Studio notebook connecting to EMR cluster. Let's look into my Okta setup. So I have an IAM Identity Center application in Okta. I have the users and groups assigned to this application, and these groups are pushed to AWS IDC. In IDC, I have the identity source created, and I'm using SCIM protocol for provisioning the users and groups from Okta. I can see the groups are synced from Okta. I can see the different users are also assigned to the groups, and I can look into the user attributes which are synced from Okta. I have these two buckets which we are going to use for the demo. I have NYC Taxi US East 1-1 bucket. This is the bucket which is governed by AWS Lake Formation. And I have another bucket, NYC Taxi US East 1-S3 access grant. And this bucket is going to be controlled by S3 access grants permission. In Lake Formation, data lake locations, we can see that I've added S3 bucket, NYC Taxi US East 1 bucket, and this bucket is going to be managed by AWS Lake Formation. I also have a table, NYC Taxi US East 1 table under NYC DB database, and this table is pointing to the same S3 location. which is governed by lake formation. And if I look into the current permissions on this table by clicking at actions and view, I can see that we don't have any permissions on this table currently. That means none of the users should be able to access this table. Now let's look into the EMR cluster setups. For EMR cluster, we first have to create a security configuration and then use the security configuration in the EMR cluster. This security configuration should use AWS IAM Identity Center for authentication. We also provide an IAM role for EMR Identity Center application, which procures Identity Center tokens from the cluster. Under the hood, Amazon EMR uses SIG-v4 credentials to relay the Identity Center identity to downstream services such as lake formation. This role should also have the respective permissions to invoke the downstream services. Please refer to the references shared in description of the video for more details. The security configuration should also use AWS lake formation for authorization.
We then create an EMR cluster and use the security configuration which we have created earlier in the EMR cluster. This EMR cluster should be using an EMR version 6.15 and above. In this case, we are using EMR 7.0. To enable S3 access grants, we also need to set these properties in EMR cluster configurations. This first property, it enables S3 access grant, and the S3 access grant fallback to IAM property. With this property, if a user attempts to perform an action that S3 access grant doesn't support, EMR defaults to the IAM role that was specified for the job execution when this property is set to true. In this case, we are setting it to false, so we only leverage S3 access grant permissions and get access denied if the user does not have S3 access grant permission on the respective bucket.
Let's look into the EMR Studio configuration now. With EMR Studio, we set the location for the workspace. We provide a role which the EMR Studio uses to access your AWS resources. On the authentication tab, we use IAM Identity Center, and we provide the role similar to the role which we provided in the security configurations. We also enable trusted identity propagation. In the application access, we can choose either all users and groups, or we can go and assign the users separately after we set up the studio. In this demo, we are going to use only assign users and groups. So we will go and assign the respective users for the EMR Studio. When we create the studio, we'll be able to see that the studio is authenticated by IAM Identity Center. Let's now see how the users log into their respective applications and execute their queries. Going back to the architecture, we have user 1 and user 2 who need access to EMR Studio to be able to execute their queries. I have two additional windows open on my right, and I will use the AWS Access Portal URL from IAM Identity Center and log in for the two users. In the first window, I am logging in as user 1. In the other window, I will log in as user 2. As you can see, when the users log in, I do not see any EMR Studio available for the users. This is because when we configured EMR Studio, we specified that the users and groups would be assigned to the EMR Studio. So we'll go and assign the two different groups, group 1 and group 2, for the two different users. We click at assign group. Get started, and we search the name of the group as it appears in AWS IDC. We assign group 2 as well to EMR Studio. Now, after assigning the groups to EMR Studio, if we go and refresh these pages here, we should be able to see the EMR Studio application assigned to the two different users. Let's look into the user 2 EMR Studio, and as you remember from the architecture discussion, user 2 is going to access EMR Studio and use EMR Studio Notebook, connect to EMR cluster and execute the Spark queries to access the table from Glue Data Catalog and S3 file from S3 location governed using S3 access grants. Let's create a workspace. You can use the default settings and create the workspace here. So once the workspace is launched, we'll be able to see the notebooks available and we can connect to the EMR cluster. You can click at the compute EMR compute option on your left and you can select the EMR cluster which we have seen earlier. Okay, so the cluster is now attached. We can go back to the notebook and we can choose the kernel as PySpark for this session, and we can write our Spark queries. So let's see how the access permissions change based on the permissions which we assign to the specific users. I have three queries here. The first query I'm reading from NYC Taxi US East 1 bucket directly, and this bucket is governed by AWS Lake Formation, so the user should not be able to directly access the bucket. The second query I have is I'm reading from a Glue Data Catalog table which is pointing to this location, and this table would be granted access to the user via AWS Lake Formation, and currently we have not given any permissions to the users, so this should fail. The last query I have is reading the access grant bucket, the other bucket which is governed by S3 access grant, and right now we have not set any access grant permissions, so this query should fail as well. Let's go and start executing these queries. As expected, the query has failed. Let's go and run the other query to read from the glue data catalog table. And as we can see, we are getting lake formation insufficient permission error. So now let's go and fix this. Let's go and grant permission to the lake formation table and see how the access permissions change. So I'm in the lake formation console, and I'm going to select grant for this table. Let me expand this. I'm going to select IAM Identity Center, which is the new feature. Add users and groups, and you can either grant access to the user directly or also grant access to the group of the user. Let's grant access to the group, and this is user 2 who belongs to group 2. So let's grant access to the group 2 user. And I will select name data catalog resources. I will select the NYC DB database and the NYC taxi US East 1 table. In the table permissions, I will go and select the select permissions and the describe permission. In data permissions, I will select all data access and click grant. Now let's go back to our notebook and rerun this query. As we can see, we are able to access the data now. So the lake formation permissions are in effect. User 2 is having access to the table, and the table is granted access via lake formation. Let's now try and access the bucket, which is controlled by S3 access grant. Let's go and run this query. And as you can see, we are getting S3 access denied because we have not yet given access to this bucket via S3 access grant. So let's now go and grant access to this bucket using S3 access grant. So let's go to the S3 console and go to S3 access grants tab, and we click at create S3 access grant instance. You can create one Amazon S3 access grant instance per AWS region in your account, and the instance serves as a logical container for individual access grants. Select IAM Identity Center, and we will get the IAM Identity Center ARN from the IDC. We go to the IDC console and we can get the ARN from here. Copy this and paste it here. Note that we are using AWS console for doing all these setups and permissionings, but you can very well use CLI or AWS SDK for doing all these things. Click next. And we select the bucket which we want to be controlled by S3 access grant. In our case, that is NYC taxi US East 1 S3 access grant bucket. So we select the bucket, and then when you register a location, we need to provide an IAM role with the required privileges on the bucket, and this role is assumed by Amazon S3 access grants. So when users and applications request access to data within the location scope, S3 access grants uses the associated IAM role to vend temporary credentials. You can either create a new role or choose from existing roles. In my case, I have already created this role earlier, so I will choose from existing IAM roles, and my role is S3 access grant location role, and then we register the location. After that, we go and provide the grants on the specific prefixes or objects under that specific S3 location. So let's create a grant for the input prefix. If you see the query on my right hand side, I am trying to read a file from the input prefix of my S3 location. So let's
select the location S3 access grant bucket and provide the prefix as input star so we can access data from the prefix named input. In permissions and access, let's select read permissions for now. The grantee type, we will choose directory identity from IAM Identity Center. We can provide access to the user or to the group. Let's choose group here, and we can get the group ID from IAM IDC. Let's go to IDC and copy the group ID and provide the group ID here. Create grant. As you can see, this has created a grant for the respective scope which we have provided and the specific permission for the specific user group. Let's go back to our notebook and execute the same query again. And as you can see, now we are able to access the bucket. You can similarly go ahead and grant different access to different categories of users using their user IDs or their groups from AWS IAM Identity Center. We can see that from the same notebook, we are able to access a glue catalog table governed by lake formation, and we can also access data from a S3 bucket which is governed by S3 access grants. This kind of hybrid access control setup can be useful in situations where your structured data, which is catalog to glue data catalog, is accessed via lake formation access grants, and raw data or unstructured data, which is not catalog to glue data catalog, is accessed using S3 access grants. Let's go back to the architecture once, and we see that the user 2 access is now handled. Next, we'll go and handle the access permissions for user 1. So user 1 would access the glue data catalog table from EMR Studio using Athena query editor. So let's go to user 1. I can minimize this, and this is my user 1 login. I'm going and expanding the screen. So the first thing which we'll do is set up Athena workgroup for the user. So let's go to Athena and create a workgroup. Let's call it a name. Choose Athena SQL. For authentication, we will choose AWS IAM IDC. We can create or use an existing role. In this case, we can create a new service role. Let's now provide the location for your Athena query results. Athena stores the results of your query and the metadata information for each query in a Amazon S3 location. You can also access the files in this location directly and work with them. You can also download the files from the query result location directly from the Athena console. So let's go and select a bucket. I have a bucket created for storing the results. Tip demo Athena QR. Choose this. And let's proceed to the next step. So enable S3 access grants is enabled by default when we are using IAM Identity Center authentication with Athena workgroups. When we use IAM Identity Center authentication, we can enable the creation of identity-based query result location that is governed by Amazon S3 access grant. When you enable user prefix option, Athena appends the user ID as an Amazon S3 path prefix to the result location. And then you can use S3 access grant to control access to that specific user location for the specific user ID. This way you can keep the query results isolated from other users in the same workgroup. let's create this work group. Once the work group is created, we will go and assign the users or group to the work group. So let's go and assign the group for this user 1. We'll go and assign groups and select the group 1 and assign to it. Next, we can go and click at the EMR Studio for the user 1, and we can log into the AENA Query Editor console. Let's switch the work group to the work group which we have created. Acknowledge. So as of now, you cannot see any databases or any tables because we have not yet assigned any permissions to this user in lake formation. So let's go to lake formation and grant permissions for user 1 on this table as well. In the lake formation console, we can see that currently this table could be accessed by the group 2 users. And now we are going to grant permission to the group 1 users as well, so that user 1 can access the table from AENA Query Editor. So let's click at grant, go to IAM Identity Center and add users and groups. Let's add group 1. Note that as we discussed earlier, you can grant permissions to the users directly, or you can grant permissions to the groups as well. In our case, we are granting permissions to the groups. Click at named data catalog resources, select NYC database, and select NYC taxi US East 1 table, and you can select permissions on the table. For data permissions, you can provide access to all the columns, or you can restrict access to specific columns. So I can go and, in this case, let's go and create permissions and apply access only on specific columns from the table. So let's go and select vendor name, trip pickup date time, trip drop-off date time, and passenger count. So the user can only access these 4 columns. Click at grant. So the permissions are now effective. So let's see what happens on the AENA Query Editor. Let's refresh this. Select the catalog, and we should be able to see the NYC DB database now. And we are also able to see the NYC taxi US East 1 table. Note that right now we have not given S3 access grant permissions on the result location. So if we go and do a preview on this table, the query should fail. As you can see, it access denied when getting S3 access grants to location S3 tip demo AENA QR, and this is the user ID of user 1 from AWS Identity Center. This is what we had discussed earlier when we enabled user identity based prefix on AENA workgroup. So let's go to S3 access grant and grant permission to this location for the specific user, and then we will come back and rerun the query on AENA Query Editor. Going to my S3 access grant console, we can see that we have an earlier grant which we had seen previously. We have this location registered. Now we will go and register one more location for AENA query results. So let's click at register location and select the bucket. This is our result location bucket. Select this. And we will use the same role. Register location. And then we will grant permission on this location. So let's click at create grant and browse the location. And in the subprefix, we provide the user ID, which is what we see in the AENA query result location, right? And this we can also check it on IAM Identity Center. We can see that the user ID for user 1 is what Amazon AENA is pointing to, right? So we can go and copy this user ID, and in our S3 access grant, we can grant permission on this prefix. So let's give read and write permission. In the grantee type, let's select directory identity from IAM Identity Center. And in the directory identity type, let's select user and provide the user ID from IAM IDC, which is same as what we see in AENA query result location. And then we create the grant. So the grant is now effective, and you can see that we have granted access, read-write access to user 1 on the S3 location tip demo AENA QR / the user ID prefix. So let's go and rerun this query on AENA Query Editor. So as we can see, we are able to see the data now, and we had restricted access to only 4 columns for the group. So we can only see those 4 columns in the AENA results output. So this completes the setup for the user 1 access flow as well. Going back to the architecture diagram, we have seen user 2 access flow, and we have also seen the user 1 access flow, where user 1 is able to access a table governed by AWS Lake Formation using IDC integrated AENA workgroup via EMR Studio. Let's now look into the Redshift access part for user 3. So this user 3 accesses Redshift internal tables using Query Editor v2, and these internal tables are created by a Redshift administrator, and the administrator also creates a Redshift data share. The Lake Formation admin can go and grant permissions on the data share and share it with the respective user, which is user 3 in this case. Let's now go to Redshift and create the required configurations. The first step is to create a Redshift application with an IAM IDC connection. This is similar to the setup which we had done with EMR Studio or with EMR Security Configuration or with AENA Workgroup earlier. So we create an application and provide the required parameters. For me, the application is already created, and if you can click this link here, I can see that this is integrated with IAM Identity Center, and I've also enabled trusted identity propagation with AWS Lake Formation. So when you create the application, make sure that you enable the checkbox. I also granted access to group 3 for this application. Then I will go and create a namespace, and I'm using a Redshift serverless cluster. So I'm in the serverless dashboard. I created a namespace, and this namespace integrates with IAM Identity Center. Once that is done, let's connect to the Redshift query editor. I've already opened the query editor console here. I've logged in as an Redshift administrator. We will create some table, and we will grant the required permissions to user 3. Let's create a table named revenue. This table has 3 columns: account, customer, and sales amount, and I'm adding 2 records into this table. The table is created. Next, we can also check the list of identity providers integrated with the Redshift by executing this query. And as we can see, we have the IDC instance
registered in this table, and the namespace is AWS IDC, which is what I had used when I created the application. Now with Redshift to grant permissions, we need to create roles, and the roles should map to the group in AWS IDC. In this case, we want to grant permission to user 3 who belongs to group 3. So we will create a role and use this standard while creating the role. So this should be the namespace of your IDC, which is AWS IDC here, colon the group name. So let's create this role. We can verify the role by executing this query and getting data from SVB roles. As you can see, I have this role added, and the external ID is same as what we have for group 3 in AWS IDC. Next, let's grant permission to this group on the schema and on the table. So up to this step, we have granted permission to the group 3 user onto this internal table revenue on Redshift. So let's go and connect to Redshift Query Editor V2 from the console and see how this works. So let's open the other window, which is user 3 login. And I have these two windows side by side, similar to how we had checked the permissions in our earlier discussions. So I have this window, which is with user 3 login, and I can see that this user has access to an AWS account, and this account has a permission set attached to it, which gives the user access to Redshift Query Editor V2. So if I go to my IAM IDC, I can see this permission set, and this permission set allows the user to have access to the Redshift Query Editor V2 via AWS console. So I have opened the editor, and I have logged in as user 3. So let's go and run a query to see the access to the specific table. So let's see, it's public. Connection, and then I will run this query. So now I'm able to see the data, and I'm able to see all the 3 columns from this table. Now let's go and revoke the permission, because we are going to manage the permissions with lake formation access control. So I'll go and revoke permission on this internal table. And if I rerun this query again, the query should fail. Okay, now let's create the data share and grant access to this user from lake formation console. So let's create the data share. I am creating a data share with the name demo data share. I am adding a schema and a table to the data share, and then I'm also granting access to the account on this data share via Glue Data Catalog. The data share is now created. Next, we will go to Redshift and authorize it. You can go to data shares, and this is the data share which we created. Click at authorize, and let's use read only for now and authorize the data share. Next, we go to lake formation, and we go to the data sharing tab, and we have an invitation, so we will go and accept the invitation here.
And let's create a database. I'm giving it a name, demo Redshift IDC, and we will create the database. Next, let's grant permissions to this database. So this is similar to our previous setups where we have granted permission via lake formation. So I'm going to grant permission to the group 3 users. Note that here you can also grant permission to the user directly. So actually we can try this out. So let's go and grant permission to the user. Let's select the database which you created, and the table is public.revenue. Let's grant select permissions, and let's restrict the permission to only a couple of columns. So for example, you may want to hide the customer information as it can be having confidential data. So let's only grant access to account and sales amount for user 3. Now after granting permissions from lake formation, let's go to Redshift query editor, and we need to do one final step of mounting the Glue database as an external schema to Redshift. So let me expand this screen. So I'm creating an external schema, demo data share IDC schema, and I am using the Glue database, demo Redshift IDC, and I am mounting this demo Redshift IDC database to this schema in Redshift. And then I am granting usage on this schema and select on all the tables inside this schema to the AWS IDC group 3 user. So let's run these statements. Let's now go to the query editor console for the user 3, and this user will now access the table from the data share, demo data share IDC schema, and we had revoked the permission for this user from the Redshift table. So this user cannot directly access this public.revenue, and it will access this from the demo data share IDC schema. And we can do a select here. Let me expand this and I'll run it, and we should be able to see the data now. Yes, as we can see now, we are only able to see the 2 columns because in lake formation we had granted permission to only these 2 columns for this user. So this completes the Redshift flow. Let's go back to our architecture, and now we will see the flow for user 3 trying to access Redshift table from QuickSight. So let's go to QuickSight, and I have a QuickSight account already created, and this QuickSight account integrates with IDC. I have given a reference for this blog which you can follow and create a IDC integrated QuickSight application. We go to manage users, and we can manage role groups and add the group for user 3, which is group 3, as an author. You can also add administrator and reader groups accordingly. So let's add the groups and use group 3. Once you add this group, you'll be able to see the QuickSight application in the console for user 3. I refresh this page and I'm able to see the QuickSight application for this user. Now, before we create a data set in QuickSight and connect to Redshift cluster, we need to add a scope that allows QuickSight to authorize identity propagation to Amazon Redshift. To do that, we can execute this AWS CLI command to update identity propagation config and add Redshift service. We can further narrow down the scope to only the Redshift application which we have been playing with. We can get the ARN of this application from IDC. We can go to IDC applications and get the Redshift application, and we can get the ARN from here. So let's execute this. So this has been added. Now let's go back to the QuickSight console for user 3 and create a data set. Using Redshift, I am connecting via a VPC, so I have used the VPC name here, demo ITC, and let's get the database. And 5439, and we use single sign-on, and let's validate the connection, and we can create a data source. Let's select the demo data share which we had created, and we'll be able to see the public revenue table. We can now edit the data, and we should be able to see the two columns. Yeah, so as you can see, we are able to view the two columns, and this has been granted permission to user 3 in lake formation. So this completes the QuickSight access path as well. And this brings us to the final part of this demo, where we will see the CloudTrail event logs for all the data access events performed by your federated users. I have few CloudTrail logs opened here. Let me expand this screen, and this is the CloudTrail event log from Redshift, and this is the batch get table event for the event source glue AmazonAWS.com. So this is the table which has been access controlled by lake formation data share, and we had granted access to user 3, and all these event logs for trusted identity propagation will have a on behalf of tag, and the user ID within that tag corresponds to the IDC user ID. So this is the user ID for user 3. We can check this from our IDC as well and match it. So this is user 3 and this is the user ID, which is same as what we are seeing here. Similarly, the other event log I have is for create data source from QuickSight. For QuickSight, we are able to see the on behalf of tag, and this is the user 3 user ID from IDC. And we can also see the access event log for AENA, where user ID 1 connected and executed queries from AENA integrated workgroup, and we can see the user ID under the on behalf of tag as well for user ID 1. We can match the user ID. We can go to IDC and go to users and user 1, and we can see that this user ID is what we are seeing in the logs as well. Similarly, for lake formation control table, which we access using EMR, we can see the on behalf of tag, and this should correspond to user 2, and this is given access to NYC taxi US East 1 table from lake formation, and we can also see the user ID corresponding to this specific user, and this is the user ID, which should be the same as what we are seeing here. So this is from the EMR Studio and EMR cluster access for this specific user. Now, if you remember, this user also accessed the data from S3 access grant. So we can see the S3 access source for the get data access event, and we can also see the same user who is granted permission on the NYC taxi US East 1 X3 access grant bucket in our setups earlier. So this brings us to the end of this demo. In this demo, we have seen how we can use trusted identity propagation feature of AWS IAM Identity Center and simplify data access management for your enterprise user IDs and groups. We have seen the access paths of different categories of users from different analytics services in AWS, and we have also seen how this enabled end-to-end audit trail for end user data access activities with AWS CloudTrail. Thank you and have a good day.